Hello everyone, welcome to the second video in discussion of 6LowPAN solution with Texas Instruments LPRF radios. So as we were discussing in the last video of the overview of the Contiki, and we discussed how the 6LowPAN stack looks like from the architecture perspective. So you have the physical layer that is comprising of CC13X for 7 GHz band and CC266 and CC258 for 2.4 GHz band. On top of this physical layer, you have the Contiki open source operating system in which all the other layers are implemented, which are the MAC, IEEE 802.15.4 MAC, the 6LowPAN abstraction layer, subsequently the routing layer, messaging layer, and the transport layer, and the application layer. So the thing is, from the devices perspective, as we know, and if we go into details of it, any typical 6LowPAN network comprises of two nodes. Two nodes in the sense, two devices. One device is the node, the router, the individual node, and the other node is the edge router. So the thing is, there is a lot of confusion from the terminologies between the 6LowPAN network and ZigBee network. In ZigBee network, as it was like the master of the network, the creator of the network was called as coordinator, and rest all nodes were essentially either router or end device. In 6LowPAN networks, the terminologies changes, and the edge router is the one who creates the network, who manages the network, and essentially provides the standard backhaul connectivity. However, the members of the network are addressed by name nodes. So you got the difference, right? So the router from the ZigBee changes to the edge router into 6LowPAN and has a different functionality, essentially the functionality which a coordinator offers into ZigBee network. So coming back to the devices defined, so you have the edge router, also called as gateway, which offers the low PAN connectivity to the standard backhaul connectivity. Then you have the host, which does not root, it's a sleepy node, and the other is the nodes which are there, and individually having unique IPv6 address of the in the network, and also accessible worldwide uniquely, as I said. So moving forward, 6LowPAN application layer. So 6LowPAN only defines an adaptation layer, as I said in the beginning, between network and TIC layer. So any application protocol that uses TCP or UDP can work. Now, common protocols like CoAP, MQTT, and in some cases HTTP can also be made to work. Now, as 6LowPAN is natively IP down to the end nodes, an application profile is not needed, because all you need is the address. That based on that address, every node's application is essentially going to access the network and the corresponding data exchange over. MQTT, again open standard, publish, subscribe to topics, host from broker, low overhead, a very simple low overhead protocol which can be implemented and which can be realized on 6LowPAN networks. CoAP, again constrained application profile protocol, comprises of client and server. So the CoAP server in the web demo application based on CC266 and 13X families in the Contiki downloading installer is running the CoAP server on the nodes and CoAP client on the edge router. Again, you can register a lot of services in the CoAP server. You can have specific proprietary to your application need services generated, created, and registered into the client server architecture, and then you can always query as and when needed. The most important part in any of the LPRF networks or LPRF solution is its certification. Now, what has been so far with the other standards like BLE or ZigBee for that matter has been that there has been an alliance. There was always an alliance which was defining, which was governing the specs, which was providing the test beds for certifying, certifying essentially all the nodes which want to comply with that specification. In 6LowPAN case, just because there is no alliance, so there is no specific entity in the world which can be approached to provide a certification. Just because it's an open adaptation layer, so anybody who just sticks to it or just want to follow the specification, he or she is free to do it. That on the other hand is, I believe, a disadvantage also, because from the interoperability perspective, it is very, very important that there is a common reference between different nodes, different products, different manufacturers, because otherwise nobody can ever come to a conclusion that who is following and who is not. So that is one of the things which I feel still missing in this 6LowPAN ecosystem. However, there is an interoperability on the IP layer because the device is pingable. So if it is accessible, it is approachable. It's all about now further refining the top layers on top of it. Many alliances exist that are utilizing this 6LowPAN layer. All Seen Alliance, IPSO, Thread Group. So all these alliances are essentially using 6LowPAN specifications, and they have gone further they have traveled extra mile by defining further top layers and different schemes for it, and then therefore offer or are able to offer a different certification procedure. So this was all from the deep how the stack looks like, how the architecture looks like, what is the background of the 6LowPAN and all. Now coming to the 6LowPAN implementation or 6LowPAN offering from the TI perspective. So what TI has in offering is essentially two examples, in which the first example shows the peer-to-peer communication, and the other example, which is the CC266/CC136 web demo application, in which the mesh capability is being shown. Both the demos have essentially the same devices in the network, that is, you have the gateway and the edge router. So the gateway role is actually realized on BeagleBone Black or BeagleBoard for that matter. BeagleBoard White can also do the job. And the open source border router application by name 6LBR runs on top of it. The BeagleBone Black or the BeagleBoard runs Linux operating system, and on top of it the 6LBR service is made to run, which actually manages the entire edge router application and function. The node functionality is realizable on CC2650 and CC136 both, and from the TI off-the-shelf hardware perspective, you can realize the node functionality on CC266 sensor tag and CC2650 EMs along with SmartRF06 baseboard, and also in the case of CC1386, you will have to use CC1386 1310 EMs along with SRF06 EB, which is the SmartRF06 evaluation board, the baseboard on which these EMs are mounted and eventually connected on the USB port. So so that is from the hardware perspective. That is these nodes, as you can see, it shows the sensor tags as a part of nodes in the LowPAN network. The BeagleBone Black acting as the edge router, and using the MQTT service connecting to the IBM cloud and offering the connectivity and unique control of each and every sensor tag. So you are also free to use IBM cloud service from TI. All you need to do is to create an account and run the demo application on the respective hardware. TI cloud partnership. So as I said, we are having multiple partners. So as of now, IBM is one of the cloud partners which we also use for our demo applications. But apart from that, there are many other partners who offer different application requirements and respective associations. Okay, so now in my last video, the third and the last video, I would be discussing in detail about the hardware and the actual setup, how does it look like, and the way you can actually create a demo and ensure that everything is working in your setup. So see you in third video. Thank you.